Did you know? Despite the Earth's abundance of water, only a tiny fraction of it is readily available for human use. In fact, less than 1% of the world's total water supply is easily accessible in lakes, rivers, and groundwater. Let us start this Class 10 Social Science chapter Water Resources by understanding about Earth's water resources. Understanding Earth's water resources, approximately 3/4 of the Earth's surface is covered by water. That's a lot of water, right? But here's the catch. Only a small fraction of this vast water resource is what we call fresh water. The kind of water we can use for various purposes like drinking, farming, and more. So, where does this fresh water come from? Well, the main sources of fresh water are surface runoff and groundwater, and these are both vital parts of something called the Earth's hydrological cycle. The hydrological cycle is like a never-ending dance of water. It all starts when water evaporates from various water bodies, such as the oceans, lakes, and rivers. This vapor forms clouds, and then, like magic, it falls back to the Earth's surface as precipitation. After that, it flows back into those same water bodies where it started. Imagine it like a giant water recycling system. This cycle ensures that water is constantly renewed and recharged, making it a renewable resource. It's like nature's way of ensuring that we have a fresh supply of water. Now, despite this fantastic cycle and the abundance of water on Earth, there's a bit of a problem. Many regions and countries around the world face water scarcity. So, even though Earth has lots of water, not all of it is easy for us to use. Let's quickly solve a question to revise what we have learned. How much of Earth's surface is covered with water? The correct answer is option C, 3/4. About 3/4 of the Earth's surface is covered with water. That is, about 71% of the Earth's surface has water in it. Now that we've explored Earth's water resources, let's turn our attention to a critical issue: water scarcity and the need for water conservation and management. Why is it so important? Well, let's dive right in and find out. Despite the apparent abundance of water on Earth, the looming threat of water scarcity persists. Water shortages aren't limited to regions with low rainfall or prone to drought, such as the arid deserts of Rajasthan. Often, water scarcity arises from overexploitation, excessive use, and unequal access among different societal groups. Freshwater, essential for survival, is sourced from precipitation, surface runoff, and groundwater through the hydrological cycle. The growing global population demands more water for domestic use and food production, leading to the overexploitation of water resources, especially for irrigated agriculture. Irrigated agriculture, which significantly contributes to food grain production, happens to be the largest consumer of water. To address this issue, there's a pressing need to revolutionize agriculture by developing drought-resistant crops and promoting dry farming techniques. These steps are crucial in mitigating water scarcity, ensuring food security, and preserving freshwater resources. Furthermore, post-independence India has witnessed substantial industrialization and urbanization, offering abundant opportunities for growth. However, the rapid growth of industries places immense pressure on existing freshwater resources, as industries are heavy consumers of water and power. Let's solve another question to test our understanding. Which sector is the biggest consumer of water? The correct answer is option C. Irrigated agriculture is the biggest consumer of water. This is because water is essential for crop growth, especially in areas where rainfall is not sufficient or reliable. Hydroelectric power plays a pivotal role in India's energy landscape, contributing to approximately 22% of the total electricity produced. This renewable energy source harnesses the power of flowing water to generate electricity, making it an environmentally friendly choice. However, the increasing growth of urban centers with dense populations has raised the demand for both water and energy, further compounding the challenge. While the quantitative aspect of water scarcity is a pressing concern, there are situations where water is available in sufficient quantities, but its quality is compromised due to pollution. Pollution sources range from domestic and industrial waste to chemicals, pesticides, and fertilizers. Ensuring access to clean and safe water is critical for the health and well-being of communities. Recognizing the importance of improving people's quality of life, especially in rural areas, the Indian government has launched initiatives like the Jal Jeevan Mission. This mission is dedicated to providing every rural household with a regular supply of potable piped water, addressing both the availability and quality of water. Let us now delve into the concepts of multipurpose river projects and integrated water resources management, which are essential pillars for ensuring the efficient and equitable use of our water resources in an ever-evolving world. Multipurpose river projects and integrated water resources management. Dams are more than just structures for irrigation. They serve a multitude of purposes, including electricity generation, water supply for domestic and industrial uses, flood control, recreation, inland navigation, and fish breeding. These projects are now referred to as multipurpose projects, where the various uses of impounded water are integrated. For instance, the Bhakranangal project in the Satluj River Basin efficiently combines hydel power production and irrigation. Similarly, the Hirakund project in the Mahanadi Basin integrated water conservation with flood control. Structure of dams. Dams are engineering marvels designed to obstruct, direct, or retard the flow of flowing water, often creating reservoirs or impoundments. It's important to note that the term dam refers to the reservoir formed rather than just the structure itself. Dams come in various types based on structure and materials, including timber dams, embankment dams, and masonry dams. They can also be classified by height, such as low dams, medium-height dams, and high dams. Adverse effects of dams. While dams offer numerous benefits, they also have adverse environmental impacts. Regulating and damming rivers can disrupt their natural flow, leading to poor sediment flow and excessive sedimentation at the reservoir's bottom. This can result in rockier stream beds and less hospitable habitats for aquatic life. Dams can also fragment rivers, making it challenging for aquatic fauna to migrate, particularly for spawning. Additionally, the creation of reservoirs on floodplains can submerge existing vegetation and soil, causing decomposition over time. Change in cropping pattern. Irrigation has been a game-changer in the agricultural landscape, leading to shifts in cropping patterns. Farmers have transitioned to cultivating water-intensive and commercial crops, which, while boosting agricultural output, carry significant ecological consequences. One such consequence is the salinization of soil, where the soil becomes excessively salty due to continuous irrigation. This transformation in cropping patterns has also shaped the social fabric of farming communities. It has widened the social gap, creating disparities between wealthy landowners and landless individuals who rely on farming. Furthermore, the allocation of water resources for different purposes has often sparked conflicts among stakeholders with varying interests. Students, did you know? In some parts of the world, rainwater harvesting can provide up to 50% of a household's water needs, reducing the dependence on traditional water sources and promoting sustainability. Let us now explore the techniques, benefits, and role of rainwater harvesting in shaping a more sustainable future. Collecting and managing rainwater from rooftops is an effective way to harness a valuable natural resource for various purposes, such as irrigation, household use, or groundwater recharge. In this system, the process begins with the collection of rainwater using a PVC pipe. The collected rainwater is filtered using sand and bricks to remove impurities. Filtered water is stored in a sump for immediate use. Excess water goes to a well for storage and groundwater recharge. Water can be later extracted from the well for various purposes like irrigation or household use, ensuring sustainability. In regions characterized by semi-arid and arid climates, like Rajasthan's Bikaner, Falodi, and Barmer, traditional rainwater harvesting practices have been a lifeline. Houses in these areas traditionally featured underground tanks or tankas for storing rainwater. These tanks could be quite substantial, some even as large as a room. Rooftop rainwater was efficiently channeled into these underground tankas via pipes connected to the sloping house roofs. Interestingly, the initial rain spell was typically skipped, as it served to clean the roofs and pipes. Subsequent rains were then collected and stored in the tankas. This practice ensured a reliable source of drinking water during the scorching summers when other water sources dried up. Rainwater, often referred to as Palar Pani in these regions, is considered the purest form of natural water. Some houses even constructed underground rooms adjacent to the tankas to stay cool during the summer heat. Rainwater harvesting in Shillong, Meghalaya. In Shillong, Meghalaya, where annual rainfall is among the highest globally, water scarcity remains a challenge. Despite the abundant rains in nearby regions, Shillong faces acute water shortages. To address this, rooftop rainwater harvesting has become a prevalent practice. Nearly every household in the city has a rainwater harvesting structure. Remarkably, 15 to 25% of the total water requirement for these households is met through rooftop water harvesting. Bamboo drip irrigation system in Meghalaya. In the state of Meghalaya, a 200-year-old marvel in water management exists, the bamboo drip irrigation system. This ingenious system taps into streams and springs, channeling water through bamboo pipes. The process begins with approximately 18 to 20 liters of water entering the bamboo pipe network. This water embarks on a remarkable journey, traveling hundreds of meters before reaching its destination. Along the way, the flow is gradually reduced to a mere 20 to 80 drops per minute right at the base of the plants. This ancient technique showcases the resourcefulness and environmental wisdom of the people of Meghalaya. Let us now see the system of rooftop rainwater harvesting in Tamil Nadu. Tamil Nadu, a pioneer in water conservation, stands as the first and only state in India to mandate rooftop rainwater harvesting structures for all households across the state. Legal provisions are in place to penalize those who do not comply with this essential initiative. This practice has been a game-changer in addressing water scarcity issues. For instance, take Gendathur, a place in Tamil Nadu receiving an annual precipitation of 1000 millimeters. With an impressive 80% collection efficiency and approximately 10 rounds of fillings, each house can amass and utilize around 50,000 liters of rainwater every year. When you aggregate this across 20 houses, it results in a substantial 1 lakh liters of rainwater harvested annually. This demonstrates the immense potential of rooftop rainwater harvesting in mitigating water shortages and promoting sustainable water use. So, students, in this chapter we have gained knowledge about several important topics, including understanding Earth's water resources, addressing water scarcity and the importance of water conservation and management, multipurpose river projects, and integrated water resources management, rainwater harvesting, and finally, the bamboo drip irrigation system in Meghalaya. These topics are essential for a comprehensive understanding of water resources and sustainable management practices.